Hello, today we will talk about anomaly detection or outlier detection in a dataset. Anomaly is the unusual, unexpected or surprising patterns which is observed in the dataset is called your anomaly. Say for example, in a banking sector, if one of the account is coming with a very large amount of data, maybe you can call that as a suspicious activity to the account and you can identify those activities. Say in finance or healthcare, if you have abnormal cash dealings, you will be able to find out that. Manufacturing industry, say one of the machine is giving you abnormally high values or abnormally low values from the machine, you can detect that as an anomaly. Or in a networking scenario, if you have abnormally high package or high traffic is coming from a specific user, you can call that as an anomaly or abnormal behavior. So all these abnormality or outliers should be detected before processing this dataset into machine learning. So for that, first we will create a dataset. I have created a dataset with a single column dataset that is called a salary dataset. I have created 6,000 values with a range from 10,000 to 1 lakh. I have created a dataset like this, and I have changed some of the values randomly with a very high value. So this is all about the data which you will be able to create by yourself. I have created a data with a 6,000 rows and a single column, values ranging from 10,000 to 1 lakh I have filled, and randomly few of the values I have changed abnormally high. So after reading the data, I will just show you the data set where I have displayed the first 10 values of your data. As you can see, fourth index data and eighth index data is abnormally high. So our algorithm, we will just find out whether our algorithm is able to detect those abnormalities or anomalies. I'm just displaying the shape of the data. As I told you, it is a 6,000 rows data with the salary column alone. So with the NumPy package, I'm just displaying the mean and standard deviation of your data. As you can see, the mean and standard deviation of data is too high. Since mean and standard deviation is very much depend upon the outliers in the data set, that is why it is displaying you abnormally high mean and standard deviation, even though I have filled my data within the range of 10,000 to 1 lakh. The mean and standard deviation shows you a very high value because of those abnormal values which I have inserted in the data set. We will discuss about the two standard mechanisms for identifying abnormalities from the same data. First one is called standard deviation method. Another one is called interquartile range method. Standard deviation method as an empirical formula of standard deviation, and this diagram is a very popular diagram for normal distribution. As the diagram specifies you, 68% of your data will be within one standard deviation from the mean. 95% of your data will be two standard deviation from the away from two standard deviation from the mean, and 99% of your data will be three standard deviations away from the mean. So with this empirical rule itself, you can conclude that 99% of your data will be three standard deviations away from the mean, and rest of the data you can call that as an abnormality because that is a very low values and that will be below 3 standard deviation from the mean and above 3 standard deviation from the mean. So this is the first method which we are going to apply on our data set. So I have created a data set and I have find out the mean and standard deviation of my data. Then I got the cutoff point as 3 into standard deviation. So I just want to find out the lower cutoff as mean minus 3 standard deviation and the higher cutoff as mean plus 3 standard deviation. So I got the lower cutoff and higher cutoff region, and I'm just extracting from my data the points which are lesser than the lower outlier and greater than the upper outlier, upper value. So these two values you can call that as the minimum and the maximum point, and the rest of the points you can categorize that as abnormalities or anomalies. So the outlier points will be those values which are lesser than the lower cutoff and greater than the upper cutoff. Again, after removing, so the other than outlier data will be the points which are greater than lower outlier and less than upper outlier. So outliers is an array which will depict you all the points which are outliers, and outliers removed is an array which will give you the data which is not an outlier or which is within the range of the lower cutoff and upper cutoff region. Finally, I'm just displaying you how many elements or how many values are detected as an outlier and how many values are detected as normal values. So as you can see the numbers, 25 values I have detected that as an outlier and 5975 values categorized as normal ones. So this is how you can apply standard deviation method to find out the outliers. The next method is called interquartile range method. This is a box plot diagram, very popular box plot diagram where the boxes represents you the 25th percentile, median and the 75th percentile, and interquartile range can be calculated using Q3 minus Q1. That is the interquartile range. And we will be applying the formula that is Q1 minus 1.5 into IQR and Q3 plus 1.5 into IQR is the lower and upper cutoff point, and greater than the upper cutoff and less than the lower cutoff we will categorize that as an outlier. That is the next mechanism that is based upon the interquartile range we will be able to identify the outliers. So the outlier points are the values which are lesser than Q1 minus 1.5 into IQR and the points which are greater than Q3 plus 1.5 into IQR. So from the data set, I am just calculating the box plot represents you the salary data in a box plot. Since you have very high large outliers, the box plot it will look like this. So from the data set, I am going to calculate the 25th quartile and the 75th quartile value, that is Q1 and Q3 I am calculating. As I told you, the IQR value is Q3 minus Q1. So that is my interquartile range. And my cutoff point is 1.5 into IQR. And the lower cutoff point will be 25th percentile minus 1.5 into IQR, and the higher cutoff value will be 75th percentile plus 1.5 into IQR. Then outlier points I will be able to find out using the values which are lesser than the lower quartile and lower cutoff and the values which are greater than the upper point. So ultimately, the non-outlier points will be the points which are within the range of lower and upper range of points. So finally, I'm just printing the length of the outlier, that is number of outliers and number of non-outlier points. As you can see the numbers, 30 points are categorized as outliers and 5970 points are categorized as non-outliers. So these are the two standard mechanisms for finding out outliers from the dataset, and this is the manual method of calculating the outliers and removing outliers from the dataset. The next video we will talk about how to automatically detect outliers and how can we remove that from the data.